Hello again. We are continuing our discussion of sequences by talking about how to write recursive formulas for sequences. So let's get started. There's two common types of sequences that we're going to be talking about. The first is called arithmetic. It looks like the word arithmetic, but because we're using it as an adjective, we pronounce it arithmetic. It's an arithmetic sequence. And what that is a sequence that's formed by adding the same amount to each term in order to get the next term. So for example, 4, 7, 10, 13, 16, I keep adding 3. That is an arithmetic sequence. 5.1, 5.3, 5.5, 5.7, I keep adding 0.2 over and over again. So that is an arithmetic sequence. The second major type of sequence is geometric. And that is where instead of adding the same amount over and over again, you multiply by the same amount over and over again to get from one term to the next. Okay, so for example, 81, 27, 9, 3, and 1. I keep multiplying by 1/3. 2, 10, 50, 250. I keep multiplying by 5 to get from one term to the next. Okay, so, and there are two types of formulas, and we've talked about this before, the different types of formulas for sequences. The first is recursive. That's the tricky one, where the nth term is expressed in terms of the previous term, which we call un minus 1. So for example, any term can be the previous term minus 6. That's how you would say that one. Any term is 4 times the previous term. That would be how you would say that formula, that second formula right there. The easier one is the explicit formula for sequences, and that's where un is expressed in terms of the term number, which is n. So if you know where it is in the sequence, you can plug that number in and figure out what that term is. So for example, un would be 7n plus 3, so 7 times the term number plus 3. Or the nth term would be 6 times 2 to the n, or 2 to the exponent, which is the term number. All right, so here's some examples of recursive rules for arithmetic sequences, the ones where you add over and over again to get each term in the sequence. So we're going to call that amount that you add over and over again, we're going to call that the common difference between the terms. So for example, 4, 7, 10, 13, 16, each term is the previous term plus 3. So I'm going to call that 3 the common difference. So here's how I write it. Each term, which I call un, is the previous term, which I call un minus 1, plus 3. Okay, so that's how I write that. I kind of think about how I would say it in English, and then I write it using the proper notation for sequences. All right, 5.1, 5.3, 5.5, and 5.7. So each term is the previous term plus 0.2 now. So each term, which is un, is the previous term, un minus 1, that's what I call the previous term, plus 0.2. And that's how I write that rule. Okay, but in recursive rules, I have to remember that I have to state what the first term is because I need to know where to start. So in the example of the first one, the first term was 4, so I say that u1 equals 4. And then in the case of the second sequence, the first term was 5.1, so I say that u1 equals 5.1. I have to do that for recursive rules only. So here's some geometric sequences. Remember, those are the ones where you multiply by the same thing over and over again. That number that I keep multiplying by over and over again, I'm going to call that the common ratio. So get used to that terminology. In this first example, 81, 27, 9, 3, and 1. Okay, so each term is going to be 1/3 of the previous term. That's how I think about it in English. So to write that as a sequence, each term, un, is 1/3, so equals 1/3 of times the previous term, which is un minus 1. Another example, 2, 10, 50, and 250. Each term is 5 times the previous term. That's how I think about it. So each term, un, is 5 times, so 5 times the previous term, un minus 1, and that's how I write the rule. And once again, just like I did with the arithmetic sequences, I need to write down what the first term is. I need to know where to start. So u1 for the first sequence is going to be 81. u1 for the second sequence is going to be 2 because that's where I started each sequence. All right, and that is how to do geometric. sequences using recursive formulas. So here's some more examples just to get you used to how this works. We're going to look at a sequence, figure out whether it's arithmetic or geometric, figure out what the formula is, and figure out the first term. So in this sequence, 3, 6, 12, and 24, I need to figure out whether I'm adding the same number over and over again or multiplying by the same number over and over again. And after some thought, it looks like I am multiplying by the same number over and over again. That makes the sequence geometric because I'm multiplying by 2. So the formula is going to be each term is 2 times the previous term. So I write that as un equals 2 times un minus 1. And the first term is obviously 3. That's the first term in the sequence. Looking at the next one, 5, 11, 17, and 23. First, I need to figure out whether I'm adding over and over again or multiplying over and over again. And it looks like I'm adding 6 over and over again. That makes this sequence arithmetic. So each term is going to be the previous term plus 6. So I write that as un equals un minus 1 plus 6. And the first term is 5. All right, then I have 97, 94, 91, 88. Figuring out whether I am multiplying over and over again or adding over and over again. I'm actually subtracting 3, which is the same thing as adding -3. So since I'm adding over and over again, that's arithmetic. So each term is the previous term minus 3 or plus -3. And that's how I write it. Un equals un minus 1 minus 3. And the first term is 97. And then the last one, 16, -8, 4, -2. I need to figure out whether it's geometric or arithmetic. It looks like I am dividing by -2 or multiplying by -1/2, however you want to think about it. Either way, that makes it geometric. So each term is -0.5 times the previous term. So that's how I would write that, and the first term is 16. So that is how you write recursive rules for arithmetic and geometric sequences. Tomorrow we'll talk about how to do it with explicit formulas, which is actually a little bit easier. So if you have any questions, please let me know, and I will see you tomorrow.